In this video, I'll show you how to use the Visualize tab to create plots of your data. If you'd like to see how to pre-process and filter your data, please see previous videos about how to operate those tabs. On the left, we have various drop-downs and fields for how to plot our data. On the right, a main plotting panel, and on the bottom, options for how to color our data. There are several plot options: Van Krevelen, Kendrick, Density, Custom Scatter, and PCoA Plots, and several options about how to plot our data. You can plot a single sample, multiple samples, compare two groups of samples, or compare two samples. We're going to start with a Van Krevelen plot of a single sample. We're prompted to select which sample and input any axis labels. We hit Generate Plot, and on the right appears a Van Krevelen plot of this sample showing the observed peaks drawn by hydrogen to carbon and oxygen to carbon ratio. We can change what we color by and which Van Krevelen boundary is set to display. This plot can be saved in a list, which you can download when you're done with your workflow by clicking this button here. We can plot multiple samples. We're now prompted to select multiple samples, and we'll start with these first 5. Again, this plot can be saved for later download. We might want to do a comparison of two groups to see which peaks are unique to a particular group. We select this option and are prompted to select groups. These have been defined in the Groups tab. We're prompted to select how we want to determine the presence or absence of each peak. We can choose either number of samples present or the proportion. We can determine uniqueness using a statistical g-test or simply by presence and absence thresholds. Depending on the method you choose, you're prompted to enter values. For the g-test, it's a presence threshold and a p-value, and then generate the plot. What you'll see is each peak displayed by a color, depending on whether it was unique to group 1, unique to group 2, or observed in both by the g-test. And we'll save this guy for later download as well. Similarly, we can perform a comparison of two samples. Though since our groups now consist of a single sample, we can no longer perform the g-test. We'll select presence-absence thresholds, specify those set thresholds, and produce the plot. Again, we'll save it for later download. These options are available for most of our plotting options, but not all. I'll quickly display the Kendrick plot for a single sample. We'll select a different one. Here showing peaks plotted by Kendrick mass and Kendrick defect for this sample. We'll save it for later download. Now I'll show an example of the density plots. We'll start with a single sample, generate the plot, and here we see for this sample the density of carbon. We can choose to plot this by nitrogen to carbon ratio or any other metadata value. We can plot the density of a chemical property based on multiple samples. Again, we'll select the first 5. And we can compare the density of double bond equivalent across these 5 samples. There's also an option to compare groups for the density plot. We again select groups, but there are no capabilities to perform summary functions for this option. We get a density for double bond equivalent for all the samples in group 1 and for group 2. Custom scatter plots can be used to plot a single sample only, where the axes represent any values in your molecular identification file. Here we'll choose hydrogen to carbon and Kendrick mass arbitrarily. Finally, we can produce PCoA plots, specifying a distance metric. We'll choose Euclidean and select the groups we would like to plot. What's drawn is each sample by the first 2 principal components and colored by which group they belong to. At this point, all your plots are saved and ready for download in the next tab.
Finally, you can link plots together by clicking the Link Plots option and selecting 2 plots from your list of saved plots in a table, and then clicking Compare these plots. If you select a region between these 2 linked plots, the same region in the other plot will be highlighted. This is for ease of comparison.